Okay, now we're live. Okay, so number 2, which of the following variables is our quantitative? And I got the number of people in a randomly selected classroom on campus.
And then lots of information, and then I guess an observational study because the students have no control. The first one.
It's the second one.
Okay.
Because they don't have control over the price of the cereals, because that's the price is what they're measuring.
Yeah.
Okay. Information. The group notices an error in their data. The age of one of the males was entered incorrectly. He was actually 21 years old. And it's not possible to determine without the full set of data.
And then for number 5, I got 2.5.
Yeah. Yeah, that's right. Okay, find the 35th percentile. And this one was one that he used a different app than we're allowed to use. So I had to I'm going to have to go back and figure it out, but it was 146.8.
0.8, okay, sweet, I wasn't far off.
Yeah, TJ, so what I did was I watched Brother Doria's recording, and that was the most helpful for me because I only missed one after I watched it. So, and I think it's just because the question was a little bit different than his, but yeah, so that'll really help you too because he explained it really well.
Yeah. And then 7, it should be skewed right.
Yep. Okay, number 8 is the one I missed, and I put 0, so we know it's not 0.
Okay, I again kind of just guessed with filling it out, but I got 2.236.
Yeah, so what you have to do is you have to use the z equals x bar minus mu over the standard deviation divided by the square root of n.
Yeah, that's what I did.
Yeah, and I just put what he did. I didn't work it out myself, and I got 0, and so I missed it. But your answer's probably right then.
I mean, it would be 8550 minus 8544.
Uh-huh.
You divide that by HM.
Yeah, in his thing, the 2 numbers were the same on top, so it just ended up being 0.
Yeah.
Okay, 9. What is the probability of a sample being passing the 50 randomly selected greater than 8540? It's 0.991.
All right. I just got the wrong one then. I just took the wrong number. And then 10, I got the probability of rejecting or not, but
it's the probability of a type 1 error.
I knew it was one of those two. I just kind of 50-50. 11, I got approximately 95% of all 95% confidence intervals. So I think that's the third one down. And then I got the last one where you're 95% confident.
Yeah. Yeah. 12, I got yes, the distribution of sample means is normal because the data are normal.
And then 13, what I was doing for this, but I put 0.020.
Yeah, that's right. 14 is dependent sampling. He needs to select couples for this sample. So whether a particular wife is selected is included depends on whether her husband is included. So
15, I got 0.096.
Yeah. 16, No, because the p-value was greater than the level of significance.
In 17, I got not necessarily, because the company needs to check that the values given by each equation are normal, not that the differences are normal.
So it's, yes, it's the third one down. Yes, the distribution of samples of mean differences is normal because the data have been determined to be normal. In the thing that the data are normal somewhere.
Yeah, I guess for some reason I thought that the data being normal didn't make it, but I don't know. I kind of just zoomed through this. I've had a long morning, so.
Yeah, I don't blame you. 18, it's H0 is UD equals 0, or HA is UD is not equal to 0. So it's the third one.
Yep. And then 19, 95% of all 95% confidence intervals, the second one.
Yeah. So 20, the answer is 50.
And then 21, no, 40, I put the last one.
Yeah, that's what I put too. 22, the last one, 51.2% of the gametes in the sample of male chromosomes.
And 23, I put 0.049.
It's 0.099.
I might have just typed it wrong, but.
What is this? Is this a... Okay, so you did probability. Yeah, these ones he did on his applet. Like, it wasn't the same as ours. Like, you just put stuff in, you didn't have to use equations. So I have to go back and figure that out. But I know it's 0.099. Or 0.010, either one. 24, suppose you're testing that against the other one, and you have calculated the test statistics UC, so 1.334. What is the p-value for this test? And it's 0.18.
And then I got the first one, and has to be greater than or equal to 30.
It's any n will do, because it's known that the level of Cocker Spaniels is normal.
Okay. Seems legit.
Okay, 26. Are the requirements satisfied? And it's no, because in at least one case, n times 1.
And then for the next one, I got P1 does not equal P2.
That's what I thought it was, but it's actually UD is not equal to 0, because I think P1 and P2 is proportions.
Yeah.
And UD is different. Is this a difference one? Yeah.
That makes sense.
Okay, 28. What does this mean? It's his actual weight loss was 5.5 pounds higher than his predicted weight loss.
And then 29. I didn't know what to put, so I just put not enough information.
It's as percent compliance goes up by 1% on average, 5 pounds are lost in 3 months. Um, 30. Okay, this is that one that we had. Maybe it's not, but this is similar to that one we had. So,
it has the same options, but it's asking something different.
Yeah, so this one is the residuals are normally distributed, there is a linear relationship between x and y, and the variance of the error term is constant for all values of x.
And lots of information and data in the end for the price tickets. I didn't know what tests or anything to use. I put 0.780.
This is regression
Okay.
because is it regression?
Because I was just having problems finding the right data, so I don't back and look at this stuff.
This one was regression, I'm pretty sure. But if you had problems with them, literally the thing that he put on there goes through one by one, and it's so helpful.
Yeah, I'll watch that before I take the exam, which I won't be taking until next week.
Yeah, for 31 it's 0.78.
Oh, so I got it right.
Yay. 32 was linear with a fairly strong positive association.
I guess I don't give myself enough credit. I understand what I'm doing. And then I'm going to get this wrong. For 33, I got 115.64.
Yep, that's right.
Hey!
The slope is 0.627.
You got this. Where'd I go? Sorry. 35, I got 240.979.
I got 241.
Okay. It says one decimal place, so I guess it doesn't really matter. Kind of gets you the same answer. But I got the information, so I'm happy.
What is the lower bound? And it's 0.518.
This one wrong because I looked at the wrong column.
Mm-hmm.
But I might still have it up. 35?
Yep.
Hi.
Okay, the margin of error was 0.109.
Sorry, my computer's acting up. 0.109?
Yep.
$39. I got the last one.
Yeah.
0. Yeah.
The test statistic is 11.509.
Okay, I probably got this wrong because I had so many data sets open, but I put the p-value at 0.
Yep, that's right. 42 is reject the null. There is sufficient evidence to suggest that the slope of the true linear regression line does not equal 0. It's the third one.
40. I suck at all of these, but I got test of one proportion.
This one is one sample t-test because we're comparing it to the 2,800 grams. Okay, 44, I figured out the difference between a T and a Z. This one's the one sample Z test, and how you tell is it's a Z test if the standard deviation is given.
Okay, that makes
That's
sense.
the difference between a one sample Z test and a one sample T test.
But they're doing the same thing, except T-test is with no standard deviation.
Yep, and Z has standard deviation.
That makes so much sense.
Yeah.
So for the next one, I got a T-test, one sample T-test, 45.
What?
45. Because we just did 44, right?
Yeah.
Okay. 45, I got one sample T-test. So, I don't know.
This one is test of one proportion because it's talking about percentages. And then 46 is test of two proportions because we have two categories.
Yeah, I got one right. 47, I got 10. But I don't know.
You got what? You
I
cut
got
out.
linear regression, the last one.
Yeah, that's right.
Sweetness. %. Woo woo.
Yay.
All right, awesome. Then
So, go ahead.
this should be our last meeting, right? Because next week's just the exam and the final project turn in,
I think.
right?
Yeah.
Okay, awesome. All right.
Okay.
Then,
See ya.
see ya.